Hello, hello. Welcome everyone. Welcome to the stream. How is everyone doing? Welcome back to another Voyager stream. So quick audio test. All good. Okay. So yeah. So yeah, it's been a little while. I think my previous stream was on Monday. Today is Friday, so it's been a couple of days. I wasn't able to stream on Wednesday. Yeah, so as I've been mentioning previously, I am actually like moving from this house. I have to move to another place. So that's basically taking a lot of my time because I need to go see other houses, other places to decide where I want to go. So yeah, that's the reason why I am not streaming as often as I usually do. Well, it's not that I always stream really often, like it's 3 to 4 times a week. Mostly my intended schedule is Monday, Wednesday, Friday, Saturday, but of course I said, that's an intended schedule. Is not something that's completely possible for me, because some weeks I am kind of busy with some stuff, so I need to use the time for other things, unfortunately. But in any case, we are back now. So yeah. So let's get into some Voyager stuff. This is what we have in progress right now, which is the entity behavior systems. Okay, and that includes what is basically the senses system, the input system, state machine, control, and interrupters. Okay, so in the previous stream I basically went through like each one of those systems and explained everything. Everything is here. I can go through right now just a quick recap. As a quick recap, I can just go through these really quick. So basically the entity behavior is not only the state machine. I will just remove this because the state machine is basically like is part of the entity behavior. So that's one of the core systems. So the entity behavior is let me make this a little bigger, like that. So the entity behavior has a number of core systems, and that's something that my idea is that those systems are going to be shared between all of the entities, like every entity in the game, whether it's the player, the astronaut, the NPCs, enemies, whatever thing that has a behavior is going to have those core systems. So we have the senses system, which is basically a class, a system that handles the status of certain properties of the entity, like if it's alive, if it's invulnerable, which direction it's facing, that sort of thing. And then it holds a reference to every detector that the entity needs. So for instance, the hurt box, ground detector. So those are detector systems that the entity might need. Each different entity is going to need different detectors depending on how it behaves or the things it does. So in the case of, for example, the astronaut is going to have a ground detector because it's a grounded entity. It's going to navigate through the ground. Okay, but for example, like an airborne entity, or like a flying entity, enemy, or whatever, flying creature, or something that doesn't walk but just flies and it basically will not need the ground detector. Okay. Then we have the input. We have the input system, which is a system that reads the input from the user, whether it's a real player or AI. In the case of the player, we get the inputs from any source that the player uses. For example, keyboard, controller. So any source of inputs from the player, from the user, is going to be read by this class. And then in the case of AI, there's a virtual brain, a system that decides what input to do based on RNG and conditions. So basically, the virtual brain is like AI in essence. So it's an artificial intelligence that's going to decide based on conditions and RNG, like random numbers and decisions. Is going to say, okay, now I press this input, now I press this other input. So that's going to be controlled by the CPU, basically. And that's how enemies are going to behave, and that's how NPCs are going to behave. So every entity that's controlled by AI is going to use a virtual brain, and the entity, like the player, the astronaut, is going to use the player input. Okay, so that's one of the key aspects of of the way I am approaching the implementation of the entity behavior. Why is that? Because basically all of the other systems are going to be the same in every entity. Like all of the core systems are going to be exactly the same. And the thing is, all of the systems, for example, the state machine and the control system that I'm going to explain briefly right now, are going to be reacting to the input. Okay, so for example, the player presses the jump button, then the control system is going to say, okay, we want to jump. Can we jump? Okay, jump. So that's very summarized, but reality is a lot deeper than that. So yeah, in the case of how I said, every system, everything uses the the same language, which is the input in essence. So whether it's a player that's deciding which input to press, or if it's AI that's deciding which input to press. But basically, from the input, then there's going to be other systems like the control and the state machine system that are going to decide what to do based on the input that's being pressed at the moment. So that's really good, because that means that we can easily debug stuff. So for example, I can use I can put the player input component into an enemy or an NPC, and suddenly I can control that entity, because the rest of the systems are going to respond to whatever input is being pressed. It doesn't matter what's the thing behind the input. They only care about the input that's being pressed, and that's really cool, because that, like I mentioned before, that allows me to maybe in the future use that as a feature. For example, if I want, I can add something that makes the player take control over an NPC or an enemy, and kind of possess that other entity, and that's kind of cool, because I don't know, it makes it really flexible. But mainly, I'm taking this approach because that's the way I thought about this in the first place, without knowing anything about behavior trees or state machines or anything like that. I thought about, okay, so what if we use the same language for every entity? So the input is whatever button or thing you press to make the entity do a thing, and we can just replace the mind that's taking the decisions and pressing the inputs without anything breaking. So that was my idea behind it, and I want to go with it. I am not like, since this is my first time implementing this way, like this kind of behavior and system for entities, I'm actually not sure if it's going to be like a lot more work than just doing, for example, behavior trees and combine with the hierarchical state machine. I actually don't know, because like so what I mean is normally, or like it's very common for games to do it like a simpler way for enemies or AI in general. So instead of doing this, which is AI presses that button and that button does this thing, the AI will just decide, okay, go to this state right now. So it's a little more like straightforward, like more direct, and I think it's like one step like one less step, instead of like the way I'm doing it, which is one extra step, of course. I don't know, maybe it's a good thing to do it this way. What I'm thinking is that maybe this makes the actual AI, or like the behavior of the enemies or things that have a pattern, or like attacks or whatever, a little more complex to implement. But I don't know. I just want to experiment with this, and we'll see how far I get, and if it's possible and easy to work, of course. So yeah, I have this little table which basically shows the comparison of systems between player and non-player control entities. So basically the systems are all like the same, basically. So you can say census is the same, input is the only different one. But you can see here, like, I don't know why I didn't use the same system here, because they are same system. So everything is using the same system except for the astronaut input. For the input system, sorry. So in the case of the player uses astronaut input, which is the class that will actually read the input from the player, like whether it's the controller, the joystick, keyboard, whatever you're using to play the game. And then in the case of non-player, meaning AI, we have the virtual brain plus a behavior tree. So it's a combination of two systems. So what this means is the behavior tree will basically handle the strategies which determine the possible transitions that this entity can do in the current context and under certain conditions. Okay? Based on that, this system will inform the input system, meaning the virtual brain, about what input is happening at the moment. Basically, this decides the input that gets pressed at a certain moment. Okay, so it's like, if you think about it, it's kind of the same as like how our brains work. It's, instead of being a human brain that's deciding when to press buttons and everything, it's going to be a virtual brain, which is the CPU basically. So yeah, that's the whole idea. And I need to actually start like making work on this, like start working on this, because the previous stream I spent the whole stream talking about this and explaining everything, which is great, but I actually didn't have the time to start actually implementing and coding. So that's what I'm going to do today. Okay, also it's not going to be a long stream today, like, well, I will say it's going to be a short stream, blah blah blah, and it's always the same length. So between 1 and 2 hours, that's basically my stream length, my average. So this stream is going to be the same basically. Okay. So give me one moment. Okay. Okay. So let's go into the scripts. So yeah, that's what we have in progress right now. You can see the systems. For example, let's go into the astronaut prefab. Okay. Let's go into the census system. So this script, this class, we already have been refactoring and cleaning it up. But I think we need a couple extra things here. So why not just go there, like census. So let me see something, because I have the herd handler here, okay, which is the thing that's going to handle the herd state and everything. Not the state itself, but it's going to it's going to handle, to manage the actual logic of the herd thing. So whenever you get hurt, and if you can get hurt and whatever. So let's think about this, because I need a couple things which yeah, give me one moment. It's really hot in here. Give me one moment. Okay, I'm back. Okay, my hair is getting really long. It's a bit funny. Okay, so one of the things that I wanted to that the census thing is needs to know is if it's alive and if it's invulnerable. Okay. Hey Lou, how you doing? Hello. Hello, welcome. Okay. Oh, look at that. I'm a 3-month subscriber to myself. Look at that badge. That's really good. Really cool. Well, it's only visible on Twitch, but it's really nice. I really like it. Okay, so the census class needs to know if it's alive and if it's invulnerable, if it's facing left. Okay. If it's facing right. Okay. Now, I think I'm just going to add this here, like that. But then I'm just going to start creating the other scripts for the other systems. So we can go here and have this as a reference. So the input class we already have. We have the census thing, which needs a little work to handle the alive and the invulnerability. And all of that needs to be handled a bit more clean. A little cleaner. The input thing is already good. Oh, by the way, I have this like I actually refactored this input controller class like not too long ago. Because like the action class was really like the actions class. Have this wasn't really like clean, and basically the thing is I have a little like I created a little system for this so that the action class is going to have a list of actions that you can do. Okay, and those actions are going to be like jump, attack, interact. Okay, so those are the actions that the player can do. And so basically with that, like the way I've done this is that I have this enum, and whenever I add a new like action here, this is going to be filled automatically. Now, of course, I need to, yeah, I think I actually don't need to do anything else. That's really cool because this class is going to handle, sorry, where is this? Here, so I have this action class. This is going to handle everything because it's going to go through the enum and it's going to get all of the actions that exist here except for this one, for none. And it's going to create a new action, which is this other class, okay, which then has a couple of variables, and it is going to be like used for whenever we do an action. Like if we want to do an action, we can set press, hold, and release, and then we have this, which is for reading whatever is happening with the with that action. Okay, so this is a lot cleaner than what I had before, because I can just simply say, for example, so for example, let me show you like a use case, because I actually have that. So in the case of jump, well, no, in the idle thing, you can see here, I can basically just do input.action.pressed, and then I say whatever action I'm pressing. And this is going to return true if I pressed. But I can also say holding or released. That's really good. And I can just say here, I can say jump, interact, whatever action. Which is really, really handy, really easy. Now, the only thing I don't really like is having to do input.action. Blah blah blah, and then actions.action type.jump. So I could simplify this by just having a string here, like jump like this, but I don't really like using strings for stuff like this. I like using enums so that I can ensure that I'm not like there's no typo like problems or stuff like that. So I know that the spelling is always going to be correct. But yeah, I don't know. I guess yeah, I could create a class, not like a subclass for each kind of action, and that could be something I do in the future. For example, if like I have an action that could be, I don't know. I don't really know if I'm going to need that kind of complexity, or maybe I will. But for example, imagine that you have some kind of special action that you can do by holding like one trigger and then pressing another button, for example, which is really usual. And maybe I end up using that, like, and implementing something like that. But like in that case, I could do something like a subclass for each type of action that there is. Like, I don't know, maybe that's something that I could do. Yeah, I guess that's something I could do. But in reality, I'm not sure, because like the way I did this is that every action is just one input, like it's not combined inputs. So I guess like for special input types, I would need a different class or a different thing for, but like, I don't know, for now, I'm just gonna leave it like this, because that's all I need for now. In the future, when I start implementing other mechanics or stuff like that, where I start needing multiple like presses, input presses to do like special inputs, or multiple inputs to do one action, then I will start thinking about this and how I can scale it. But for now, this is more than enough. The thing I was going to say is that the axis class is not great. So yeah, I have like a bunch of booleans that could be just all of these could be easily like cleaned up by creating another action, and I don't know, another action, another class, I wanted to say. So that's for another moment too. For now, this is also functional, and if I start like refactoring everything, I will never make progress on the actual thing to have a playable thing, at least. So this works, and I'm gonna use it, and when the time comes for, I don't know, improving this or whatever, I will do it. For now, this is more than enough. So what else do I need to start thinking about? So I have the census class, I have the input, I have the state machine, which is perfect. I have the state class, which is also perfect, which, well, not also perfect, but I need to do a couple things here. I also need to do a couple things in the state machine class. For example, the state machine keeps history of the recent states, which I already have like a reference to the previous state, which is useful. Maybe at some point for example, I could need like a stack of recent states, like an array or a list that updates every time. But yeah, I don't know. But that's I can't really think of a use case for that right now. So let's keep it simple for now. For the state class, well, there's a couple things I need to do, because as you can see here, I have like actual input checking here in the state itself, which when in reality this shouldn't happen. Like the only thing that should happen in the state is actually just handling the logic for that state, whether it's I don't know, if it's running, if it's the run state, it should handle the speed of the entity, and that's it, and not worry about which input is being pressed or anything like that. So what I should do in the state is like on the other hand is, for example, if I see that the entity has like 0 movement speed, for example, in the run state. So here, instead of me checking this, like if I'm attacking, or if I'm not moving this, I should be checking just this, for example, which is moving X, and I have a threshold for like the actual velocity. So whenever the velocity is like moving below, like if the X velocity is below this threshold, then it means that we are not moving horizontally anymore, and it means that we need to transition to idle again. So, and also the transition itself also shouldn't be happening here. Yeah, what should be happening here is just calling on complete. I don't know if I have that. Yeah, I don't even have that event here, because like my idea of the states was totally different. But like this is not like terrible. But for example, look at this. This is something I showed in the previous stream too. So you can see here I'm checking action inputs to see if I'm pressing the attack button and then transition to the shoot state. Okay, so that's fine. Like while you're running, you should be able to transition into the attack state. But that also should be checked if you're in the idle state, and that is the case. But you can see the problem here. I have repeated code here. You can see it's exactly the same code. So of course that's not a good practice, and it's not scalable, because that means that for every state that can attack, then I need to copy this code and paste it there. So that's why I need to implement the control system, which is basically what handles the transition between the states. Okay, so that's one of the things that I need to do. So I guess I'm going to call it behavior control or something like that, because that's a bit more specific to the behavior system. So I'm just going to do that. Okay, so in the behavior, here you can see we have the actual like objects of each one of the contexts, okay, for each state. So this is another thing, like this is basically for a hierarchical state machine. This is the basis. So you have the grounded context. So whenever we are grounded, we can do those states. Then when we are airborne, we can jump. Well, in reality, the jump is a state that belongs to the airborne context, but we can do the jump only while we are grounded. So yeah, I'm kind of torn with this one, because I don't know. In any case, then we have the climbed context. So But like the idea behind having contexts like this is not so that the states that can be done under that context are like live there. The idea is that the states will share some kind of logic from the context. So in the case of grounded, all of these states are going to be checking if we are grounded, because the base class called grounded is going to be checking that. So all of these states are inheriting from the grounded state. Okay, so that's in essence just a hierarchical state machine. Okay, my hair is not great today, but it's fine. So let's just think about this, because I have this behavior state machine and I'm thinking like, should I actually just add, for example, the well, I should be working on this in the entity prefab actually, because like I mentioned before, this is not something that's only relevant to the astronaut, but also to every entity. So I think I should remove this, because it's not only going to be the state machine, which is the entity behavior, but it's also going to have a couple other scripts, which are the control and the behavior interrupter. So I need to create those things. So let me just go here, and I have this folder. Okay, I have this generic state thing. I'm gonna move that to another folder called generic state. Okay, I'm gonna move that there. Revise. Okay, then I have the entity behavior and the entity state. Now, actually, the state class should be under the core state machine. So where, yeah, here it is. Because the state, I have a core state machine, which is like the abstract form of the state machine that can be used whatever, for anything like UI or anything. Like you can think of a door, for example. A door could use a state machine. Like it's going to be a bit overkill to use a state machine for a door because it only has two states, which is open or closed. But just to give an example, you can think about a door as having, well, exactly that, just two states, which is open and closed, and I can use a state machine for that. It's like not worth it, of course, because I could use just an enum for that, and a much simpler system in just one script instead of using multiple things and creating one script for open and another script for, like, it doesn't make any sense. But it was just to give an example of like the possibilities of the state machine. So yeah, now let's go again into entity behavior. Then we have entity behavior, entity state, and we need to create another script called, this is going to be behavior control. Perfect. And we're going to create another one. Okay. Which is going to be called I'm going to call it behavior interrupter, okay, which is this one. So the behavior interrupter handles the interruptions of any state, and the state machine asks if it's an allowed interruption before transitioning to the result state. Okay, Now I don't know if the state machine is the one that's going to be asking that. I think it's the control class that should be handling the actual interruptions. So yeah, I kind of need to think about like how this would work, because like, for example, what could be an interrupter? Well, it could be hurt, so I need to actually add that here. It could be hurt, it could be a cinematic, etc. Okay. Well, death. So those are basically states, okay. Those are states, or those are also interruptions. So yeah, I need to also think about how I will implement that. But for now, let's continue with the behavior control, and that's gonna be here. Okay, so now behavior control. Now, what's the thing with this? Now, the thing is, the behavior control okay, let's just start by what the hell? Oh, I have the copilot thing activated, so I'm just going to disable it. Now I'm going to do namespace Neptosmic.Voyager. Okay, perfect. And I have this base class. Okay, now what does this base class have? It will have a reference to the entity behavior. Okay. Which in reality, I think it's just the machine. So I'm just gonna call it machine. So you can see here. Well, yeah, I can just call it behavior. Yeah, okay, so yeah. So here I'm going to call it behavior, okay. Okay, perfect. Yeah, now here this should be called a machine. Perfect. Yeah, I'm trying to start trying to change and rename stuff so that I use like a proper naming for the variables. So here in the entity, like the state has a reference to the machine. The entity state has a reference to the machine too, and entity behavior is the machine, is a class that inherits from the machine. So in this case, I did this little like property. This is a property, and I'm basically doing like not casting, but like accessing the machine as an entity behavior, like this, and the entity state should be using the machine. The behavior reference, because the behavior reference has a reference to the entity and whatever. Okay, so you can see here I have like a lot a lot of shortcuts for accessing the things in the entity. So I need the animatosmic, the input, the senses, the stats. So that's kind of what I have been explaining on the systems. But now the thing is, like, I do need a reference to those things. I think I don't need a reference to the input because we are not going to be reading inputs in the states. I think, like, that's the idea. So yeah. Yeah, so then the behavior control is going to have a reference to the behavior. Then I need to initialize this. So the behavior control is going to have this reference. I'm gonna make it protected because then I'm going to inherit from this class and create other types of control for the different contexts. So what do I mean about this? Basically, I'm going to have, like, I'm going to be doing different checks and different transitions depending on the context that you're in. So for example, I have the ground control, which is going to contain states that are under the grounded context. Okay, so that's great because we then can like separate and like modularize each one of the contexts for the behaviors. So yeah, I think I should actually just remove this from here. Not remove, like close those, because I'm going to move the script to another folder and I'm gonna have to open the file again. So behavior control. Okay, perfect. So now the idea is, I think this makes sense, but like my idea is this. So let me just copy this, paste it here. Okay, whatever. I can just move this here. This should go under this group, and this, yeah, okay. So I need to remove this, and what I want to do is this. So imagine the behavior control. So this should be like not italic and should also be a little bigger. So what's happening with the behavior control? My idea is that then inside we would have, for example, ground control. Okay. And then inside ground control, we would have the states. So for example, idle, run, I don't know, attack. Then we would have air control, and that would be, well, jump would be also under ground control, I think. No, I actually think they should go under air control, because the thing is, whenever you jump and when you are inside the jump state, you are actually like already controlling the player, like the entity in the air. So jump, fall, jetpacking, etc. So then I can have another one called climb. It could be called climb control or something like that. So that would be ledge wrap. Let's climb. Okay. So what I'm thinking with this is basically the control system is the thing that's going to be actually controlling the transitions between the states. Okay, that's the idea. So whenever we're in the ground control, we're going to be moving between those states. Okay, so I think it's not going to be like I don't think I can have well, it's possible, but I don't know if I can have this be something like general and usable, like global. So I don't think I can do this for every entity. So like create just one script called like ground control and then use it in every entity, because some entities can run, some entities could attack, or yeah, of course, I forgot about interact too. So like not every entity will be able to run or attack or interact. So I think I should just be able to, for example, I should have like in the case of the astronaut, I would have an astronaut ground control. Okay. Yeah, that's the thing I'm trying to think. I guess I can have like the generic classes for these ones. Like for example, I can have this, which is ground control. Okay. So yeah, I think this is how I would do it. So I would have like something like this. Can I do an arrow like this? And then I will have like I need to group this. Duplicate this, move it here. So in the case of the astronaut, for example, I would have astronaut, ground control, then astronaut. Okay. So then I would do here, I would say check for grounded. Okay. Like Okay, then here I would say only runs when not grounded. Then here only runs when climbed. Climbed. Okay. That's the whole idea. Something like that, I think. And then here in the astronaut ground control, I would have idle, run, jump, attack, interact. Then in the air control, I would have, not jump. I would have jump here. I would have fall, jetpacking. Then here I would have ledge, grab, ledge, climb. Okay. So those would be the transitions that we can do while we are grounded, okay? And we can also oh yeah, so that's the thing. So from the ground control, okay, and then the same thing for this, and then for this. So from the air control, we can transition into the fall state and into the jetpacking state. Not to the jump state, because we don't have a double jump. Then from here, oh yeah. Okay, yeah, so yeah. Okay. I'm starting to like organize the things in my brain. So okay, that's the idea. So the behavior control handles transitions. We have the ground control, the air control, the climb control. Okay, so those are basically like layers that will be handling the actual states. So I think that makes sense. So here I have behavior control. Okay, and here, well, so here in the entity behavior, I think I have something here which is like I have this dictionary of states, and I populate that dictionary when I initialize the state machine, which is in the start method. Whenever the application starts, and this runs once, and is going to go over all of the children. So this is basically populate states. Okay. And I also should be doing the same thing Okay, in the entity behavior, well, I should add the region. And here I should override the init function, and I should also populate control. Okay, so how would I do that? I would do basically the same thing here, and also I need a reference to the dictionary. So I would have a dictionary. Well, do I need a dictionary for that? I don't think so. Yeah, I think I can do that manually. I'm gonna do it automatically, I guess. I'm not going to have like hundreds of, not even like more than 50, not even more than 20, not even more than 10 entities. Like, no, I think maybe 20 entities in one like space. So I think that's gonna be like more than fine. So I guess I need a list. Do I need a list of this? Yeah, I think I do need the list. So this is going to be behavior control. I'm gonna do this. And then whenever I do this, I need to do... what did I do with this? Oh yeah. All states, get component children. Is that an array? Yeah, it is. So I'm gonna do an array of this too. So why is this like that? Whatever. So behavior controls equals get component in children, behavior control, components. Okay. Great. So now I would have the list, and then I will go through each one of those. And I will initialize it with this behavior, entity behavior thing. Okay. So that's great. It's basically the same thing that I did here. I'm basically getting all of the states that live inside this transform. And then I am basically just adding them to the dictionary and then initializing them. Here, I don't need to have a dictionary of this. So that's completely fine. So all I need to do is get them from the thing and then okay, yeah, I think this is fine. So now I have this. Like I get all of the behavior controls that could be living inside this entity, and then I initialize them. Okay, and I set the thing, like the reference to the behavior, and then well, then I have this, okay, which is the update method. Okay, 1 second. So I have this, and I think this should be running in the update method, okay? And Okay. Yeah, so trying to think like what's the best way of doing this, because each behavior control is a mono behavior, okay? And like having so many mono behaviors is not the most optimal way of doing this. I could actually just make this like a whatever. I can even do this, create this as an abstract class. But yeah, it doesn't let me. So, well, whatever. The thing is, having mono behaviors of everything is like not the best thing, but it's just such a convenient way of doing this, because it's just going to be just having a component that I can add as, like, for example, in the case of the astronaut, I would have like in the grounded thing, I would have the ground control, and then I would have all of the states, right? So that's really cool. So yeah, the other thing I could do, so I'm trying to think what's the best strategy here. So like the thing is, I could do something like I could have like the entity behavior, okay, and then make this a regular class, and then make the entity behavior update the control, the behavior controls, okay. And that would mean that I can basically just create, for example, an astronaut behavior, okay, and then the astronaut behavior would be the class that contains the actual references. Like, for example, instead of doing this and getting them in the child or whatever, so like instead of having one mono behavior pair behavior control, so which is not a big deal, because like how many behavior controls can like an entity have? The case of the astronaut, which is, let's say, the most complex entity in the game, is going to have ground control and air control and time control and I don't know, water control. I think that's it. Like, there's no like more contexts than those, I think. So I don't think it's that bad. But if I would like make this a regular class instead of doing this, for example, like what I could do is have an update function here, okay. It's like the thing that I need to use from the mono behavior class is just the component thing that lets me add this as a script into an object. But like but yeah, I could actually just make this a regular class and just go here, and in the case of the entity behavior, I would just say, for example, I don't know, astronaut imagine if I had like an astronaut behavior. Now, that's the thing, if I do that, then that means that I can't really use this same class for every entity. I would need to replace this with the astronaut behavior in the astronaut prefab, and then each entity type would need to have its own behavior class, which I don't think it's like the best thing ever, honestly. So I think this way is the most convenient for what I'm trying to do. So I'm just gonna stick to that. Now the thing is, well, actually, I could make this a script, like a scriptable object. But I'm not sure. Like, just yeah. For now, let's just keep doing what I was doing. Anyways, I have to go soon, but let's keep doing this. The other thing I wanted to actually do was go here and basically just override updates and go through, like, well, maybe just here create another region and say local. Update behavior controls. So here I would say update behavior controls, okay, in the update method. And then here I would do this behavior controls dot length, and then behavior controls index I dot update behavior. So this in essence would have an update function, which, you know, actually feels a bit dumb, honestly, because this already has an update function because it is a mono behavior. So I'm thinking that maybe I should do this in the behavior control itself. I think that makes more sense than doing this. Yeah, so the thing is, I'm trying to think like of an easy way for me to convert this into a regular class, not a mono behavior, and still be able to add like each behavior control as a component into the entity that needs that behavior control. So for example, when we talk about the astronaut, I need a grounded control and an air control or whatever. But then if we talk about, for example, an aquatic creature that can only exist underwater, and its behavior is going to be only underwater, I only need a water control for that. You know, so I don't want to have a grounded control for that entity. So yeah, I'm trying to think of like an easy way of doing this kind of thing, like having the things be mono behaviors. So yeah, in any case, I have to go now, so that's something to analyze in the next stream. Okay, so yeah, I'm just going to comment this here, and we're gonna leave it here for now. Yeah, it was a kind of a short stream, but yeah, I don't really have much time these days, but oh yeah, I think I need to do this actually. So yeah, as I was saying, I don't really have much time lately because of what I was mentioning before. I'm moving from this house, so yeah, until I'm moved to a new house and I'm like settled and everything, my schedule is going to vary and be a bit like this, where I may stream some days and some other days I don't, and whatever. And maybe my streams are a bit shorter than usual, so yeah. Yeah. So, yeah, we are working our way through this slowly, but we are going to get there. This is a really complex system, and it's like I'm trying to think. I will try to avoid like thinking that I'm stuck on this, because it actually is a really complex system, and once I have that like the system actually implemented and working, it's going to be so much easier to implement more and more entities. Like, it's going to be so much easier. So yeah, that's my idea basically. That's what I'm trying to do. That's why I'm spending a lot of time thinking about the system and how the best way to implement it and everything, so that it's easier to scale, to add more stuff, to extend, I would say, and to implement any new entity should be easy to implement and get like functioning really quick. So that's the whole idea. Okay, so that's gonna be the stream for today. Thank you very, very much for watching. Don't forget to join Discord as always. If you want to get notifications when I go live, just consider joining the Discord. I always notify everyone there when I go live. And then, yeah, you can also share your stuff if you're working on some game, or if you do art or anything. You can share it there. You can get feedback if you want to. Whatever. It's a great place to hang out and to share some stuff. So I always love seeing what you guys share there. So that's really good. Okay, and also, if you're watching from YouTube, consider subscribing. And if you want to support my project and everything, just consider subscribing on Twitch, or just going to my Ko-fi. You can go there and donate. That's really, really appreciated, because as I mentioned before, this is just a passion project. I'm not making any profit from this while working on it, so I would really like to work on this full time and to live off of this game. But for that to happen, I need to release it and to sell it, and for it to do well in the sales. So in any case, that's gonna be the stream for today. Thank you very much for watching, and I will see you in the next one.